We will all be here to celebrate our nation's independence in July. This is great. Nothing better than snow days.
Nobody's going on. You're not the only person that's saying.
Is that what happens?
But hey, why don't we like take off days that we have off?
That is an option. It depends on how the school board goes about things like that. I know other districts have done that. Districts that let's see. I think my mother-in-law's school district. What they've done is they've shortened up certain things. Like they got rid of President's Day, came to school on President's Day. Some others, like for example, we have an Institute Day coming up next week. Some people, sometimes they cancel Institute Days to make it a school day instead. So there are ways of saving days here and there. But I think as of right now, since we've only used 4 snow days, I don't think they're going to worry about that until if they have to use more.
Like 6.
I'm with you. And to be honest with you, I would rather we would start like a week earlier.
Yeah.
But then we still have the issues with there's not everything's air conditioned. But if you remember in October, they had to close the building early anyway because it was too hot. October. So it's just a weird year. Yes, sir.
If we miss one more day, I'm not gonna be able to go to
Oh, I know, and I think there's also
it already goes right to the end of our vacation.
Yeah,
So right
and-
now we have to leave right when I come from school.
there's also waivers that the state has done. There are times that the state will say you're exempt from having to make up these extra days because of so many different things like that. It can happen. I haven't seen it happen in the past, but I do know that things like that do occur.
I thought they already called a state of emergency for the first 2 schools.
Well, they did, but it doesn't. We still have to make those up. I'm just saying, there's a lot of weird things that can happen, but it's all dependent upon what the state says. But I don't believe the state half the time because they owe us a lot of money. So that's that. I don't know how it really technically works, but I just know about the number E. It's just weird because it's a number, but it's a letter. So text your mom about that, and we'll call it a day, right? Hey, what's up? Now that we're going back on track here. Yes, sir. Last thing.
So what day do we?
As of right now, Friday the 13th of June. It's a day of horror.
Wait, that's a great idea.
Number E. Number
Finals are gonna be like pushed back
13th, 12th, 11th.
Okay, I'm
I don't know. Don't ask.
Probably could take it in advance.
Oh my Lord.
Let's just get this over with.
Ladies and gentlemen, this should not take very long. The number E. Welcome to Euler's number. Euler. E-U-L-E-R. The Euler and Pythagoras were good buddies.
Were they really?
It does look like Euler, but it's pronounced Euler.
Oh, that's great.
Why? I don't know. He's old and he's dead. I can't ask him.
Why do you, how did you come about to that?
Euler?
Yeah.
That's how I always thought his name was pronounced Euler.
What was your teacher's reason?
Bueller without the E.
It's just one.
So much for having fun. Anyway, basically what Euler was able to come up with is that if you take if you basically take this as n approaches positive infinity, you don't really need to know all of this part here. I think they use this as a 1 though, 1 over n. It's approaching the same value. It's getting closer and closer and closer to this magical number. And this number is represented by this.
Ooh. Is that magic? Oh boy.
Paul McMatheny here. Big number 9, a great mathematician, Mr. Euler. When I find myself in times of trouble, wise teacher comes
Yeah, I was just thinking that.
speaking words of wisdom, letter E. In my hour of darkness, he is standing right in front of me, speaking words of wisdom, letter E, letter E, letter E. Waiting for the glass to shatter. Whisper words of wisdom, letter E. When it's the base of a logarithm, everyone will agree. There will be an answer, letter E. There is a situation, it is natural for all to see. There will be an answer, letter E. 2.7, 182, 818, 284, 5904, 523, 6, 028. Oh, God.
Sweating a little bit.
5266, 249.
What? Why does he have a guitar hero thing?
I think that's rock band.
All right, it kind of goes on from here. It's really not.
There is compounding that reminds
And that dude's just a teacher.
I don't know.
You know how funny that'd be?
I don't know. It's horrible.
You did that?
Yeah, it would be.
So
It would be funny. It would be something I would do too.
I would.
Basically, what happens here is this Euler dude figured out it was as n approaches infinity. You don't have to worry about what this actually means, but as n gets larger and larger and larger, the value that it's spitting out for its y answer is approaching this 2.71 in change. It's an irrational number, just like pi. It's a never-ending decimal. It does not repeat. So there are people that try to. Remember, I've talked to you guys about people that want to recite pi to thousands upon thousands of digits. Well, these guys are even worse. Yes, sir.
When you say it never repeats, what type of segment will be repeated?
What I mean is, if you look at repeating decimals like 0.3 repeating, it just goes. It's just a repeating recursive.
Oh, right.
It just continuously goes like that. Or if you have like 27272727, something like those. There's nothing that significantly repeats itself. It doesn't come into a cycle where it just continues on in that same pattern infinitely. So it's a that's why they call it non-repeat. All right.
There's 1 8.
That's the whole reason why I've had that thing on there for you, just to annoy you, and it worked. So what happens here is that we can use log base, or excuse me, the e value. We're not in the logs yet. Excuse me. We treat it like we would. We're going to do 3 things with it today. We're going to talk about how you can use it via simplifying using your exponent rules that we've done in the past. We're going to talk briefly about how to graph it. We'll do a little bit more of the graphing tomorrow. And graphing in E is not anything like what we did with AB to the x minus AH plus K, where we had the shifting here. E is a much, much, much easier thing to graph because you really only know one value, and that's going to be your y-intercept. The rest of it's all calculator based. So we don't spend a lot of time on it. Then lastly, we use E more for compounding interest problems, similar to what we did with exponential growth, where we did the compound interest where it was rate over n for the number of times things were compounding. Well, we use E now instead when we talk about something called compounding continuously. So there's 3 little things we're going to look at today. First of all, let's talk about what we do about simplifying with the letter E. Again, treat it like it was a variable if you want, instead of an actual numerical number. So if it's e to the 3rd times e to the 4th, what do you do with the exponents? Add them, so what do you get? All right. Now,
You can use a calculator.
does it spit out the answer in e's?
Yes, it does.
I didn't know that.
Well, not in ease, it spits out the answer in a big number.
That doesn't work.
Yes, see, that's a little different.
Why doesn't it work?
Because you need an e in there. If there's an e in your, if it starts in an e, you got to end it in an e.
Oh,
You don't
1,000.
have to.
Jeez.
It gives you 1,005.
Again, in this case here,
Because you can actually.
2.
10 over 5 is
2.
e to the 3rd, e to the squared. E. or not 2e?
No.
That's the question, I guess.
Now, the next one is usually where people get a little weird with.
That's,
Why don't you move it?
no.
Take a look at what's going on here.
It's not.
Well, hold on, before we worry about things that are happy or not happy. We agree that it's all being raised to the squared power, right?
Yeah.
So basically you have to distribute out what's going on. So we have 3 squared, and then it's e to the negative 4x squared as well.
Oh, what did we, I thought that's a sin.
Wait.
Nothing's a sin here. All I've done is think about what we had in the past. It was 3x to the 4th, and we squared that. We have to go 3 squared x to the 4th squared, right?
Oh, I thought it was 3x times 3x.
So in this,
Yeah, jump
I thought it was
times
the
jump.
jump times jump.
Jump times jump.
You understand what we're saying?
yeah, I understand what you're saying, jump times jump. You can do it that way. Well, let's say it was to the 4th part of this. You don't want to do it that way. You want to go jump, 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 do you?
Personally,
No.
no.
Exactly. That's why we can use exponent rules. But you're right. If you want to go jump times jump, it works out just the same. Okay. So if it was, we'll just go back to the squared part. You get 9x to the 8th. Would you agree on that?
Yeah.
Power to power, you multiply. Again, this is 9. This is where most people start to mess up. Negative 4x, that is the exponent. So you just have to multiply it by 2.
Oh.
Because the negative 4x is the exponent, so the x is part of the exponent. So you just have to, the rule is exponent raised to another power, all you do is multiply the two together. All right? So now it's just not happy, and it becomes 9 over e to the 8x. Again, the reason why it is not an exponent with a square, it's not 8x squared, is because the value of x is the exponent. And the rule is when you have power to power, exponent to exponent, power to power, you just multiply them together. Okay? That was the rule from way back. And that's usually the screwball one of them all because it looks a little bit different than what you guys have done in the past. All right? Does that make sense? Because they're used to distributing all the way through with variables, but now it just happens the variable is part of the exponent. All right? Okay? Don't worry about that. There are 2 different ways. Don't write all this down. When you're looking at graphing with E, again, in order to be able to tell whether or not it's growth or decay, all you have to do is look at the value of the R value of your exponent. So what E uses for its generic, if you will, you have Y equals, I forget to put an E in there, or A times E to the R X. And obviously there will be an H and a K later, but like I said, when we graph these things, it's mainly going to be calculator based. I'm not too worried about sketching any of this stuff by hand. In order to tell if it's going to be growth, if R is greater than 0, it's growth. If R is less than 0, it's decay. And that's basically all I need you to worry about for graphing as far as right now. Okay? Again, when you're looking at these things in a calculator, when you have these exponential growth, exponential decays that are dealt with natural base E, we're just going to be working with these things usually on the calculator with your table. Because there's no easy substitutions to give us nice ordered pairs like there were when we did the A, B, H's, and K's. Those you were able to use some simple numbers to substitute in and get nice integers to plot. In this case here, you're not going to get as nice of an integer. Let me show you an example real quick. And I know you don't have any graph paper, you can kind of get the idea of what this is going to look like. In this example, I have y equals 2 e to the 0.75x. Okay. In this case here, first thing I want to know, is it growth or decay? It's growth because the R value is positive. Okay, so you're halfway done. At that point then, the easiest thing to figure out is, well, go to your calculator. put that in your y equals. It was, let me show you where the buttons are for E. 2. Now, if I'm going to use my calculator to put E to an exponent with an exponent then, hit second ln. It stands for natural log. Natural log.
Why is it backwards?
Why is it
Be-
backwards? Yeah.
Because it used to be log of the natural base.
Oh,
That's true.
Ellen.
I don't know.
Doesn't matter.
1936.
All right.
You're welcome. And now it erases the exponent 0.75, and then it's 3 variable in.
Wait, where's the button at?
The button is at, you hit second ln, it's just to the left and up of 4. So it's just 0.75 right? Yeah. And hit your graph real quick, and you'll see that it looks like just a regular exponential growth problem.
What?
And now, what happens here, what I want you to do is look at your table. Look at your table, because now you're going to be able to see how you're going to get these intercepts and stuff. Because what happens when x is 0?
Why is that 2?
It equals 2. And think about what's going on here. If x is 0, what's 0.75 times 0?
0.
What's e to the 0?
1.
What's 2 times 1? So again, this value of 2 is still going to be my y-intercept because there's no h and k tacked on.
What was the R value?
The r value is this
Oh,
here.
it's- Okay.
Okay. And then, obviously, when you go back to the table, everybody see how it's giving you really nasty looking decimals?
Yeah.
That's what you're looking at, just plotting a rough idea of what they are. Again, if we're talking about graphing with E, it's mainly going to be, can you identify the intercept? That's about it. Can you identify the intercept and you figure out where your horizontal asymptote's at? Gee, where do you think your horizontal asymptote was in this graph? What's that? Did you say it correctly? Oh, you see where you did? There you go. All right. Not so bad. Again, what's going to happen here, we'll talk a little bit more about graphing stuff tomorrow, because I'm going to split this up over about 2 days worth of work. It's not that much, but I want to give you more chance to graph stuff tomorrow. We'll get a little more fancy with it. We'll skip this one. But I do want to talk about how this works via compounding continuously. If you go back to what we did, I don't know, about a week ago, we talked about that for compounding interest problems. When we talked about interest being compounded annually, semi-annually, quarterly, or daily, those are when those n values were coming into play, the number of times things were being compounded. The r value was your percentage as a decimal. But now what's going to happen is that the problems may be worded a little bit differently. It could say that it's compounding continuously. Compounding continuously mirrors the idea of compounding interest daily. Okay? It mirrors the idea of compounding interest daily. So if you are compounding continuously, you have this new generic idea, PERT.
The shampoo?
Yep, we're working with dandruff.
I use that shit.
I do too.
There you go.
This is your rate again. It's a percent as a decimal. And T is your time. It's usually in years. Okay? It's usually in years. So you'll be able to get a little bit, it's a little bit of an easier formula to work for, but the only time that you can use it is if the problem states continuously compounding, or compounding continuously for the interest problem. Okay? It's the only time you can use this one. Otherwise, if it says semi-annually, you got to go back to the R over N. Okay? So let's look at an example, and you'll see how very, very, very simple this is to use. You deposit $1,000 in an account that pays 8% annual compounding continuously. What's the balance after a year? Again, when you set something like this up, the easiest thing to do is your initial amount $1,000. Your rate is 8%, 0.08. And then your time is 1, because it says after 1 year. You use that in that PERT formula, if you will. The amount, 1,000. E to the 0.08. There's 1. 1083. You guys get 1083 and change?
Yes, I believe that's what we're working on.
Is everybody able to find the buttons as far as the E button to raise it to exponents, okay?
Yeah.
The E button is on your calculator twice, believe it or not. There's that one, and there's one above the division symbol.
Right.
If you use the division symbol, you have to hit the caret.
Way too much work. Yeah,
Nah,
way
yeah.
too much work.
Works either way.
All right.
It works either way.
Homework time.
Not so scary.
No.
It's not serious.
Again, when you're talking about
It's gonna get worse.
when you're talking about working with E, it's a sometimes they'll have models given to you in terms of it. You can still identify what the principal, what your initial amount was. You can figure out amount of time something that lapses. In this case here, it says in 72, the Fish and Wildlife Service kept a list of endangered species in the U.S. For the years 72 to 98, number of species S can be modeled by blah, 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 blah. Where T is the year since 1972. What was the number of endangered species in 72? What was your initial? Oh, 119? Yeah. 119.
119.6.
No, 119. I don't think they had, remember, we've argued about this.
Katie, be a second service.
Are you going to graph this?
No.
No. So if I'm going to figure out, to estimate the number of endangered species reached 1,000, what am I going to do? How do I use? Wow, you guys have all listened to me the past couple of days. This is crazy. You're overachieving. Yes, that's you. Was it 119? Or what?
119.6.
Oh, I used it. What was the 0.09? Again, go to your table. Good. Good. And just scroll around looking for 1,000. Now, whatever many years it was. Good. So about 23 years, 24 years. So between 23 and 24 years after 1972, so we'll say, what would that be, 96? 95, 96, somewhere in there?
95.
You can say June of 95,
Yeah.
because it's halfway between, right?
That's humor.
That's funny logic there.
Humor. Is it humor? That's humor.
Month, a year. No. I know I'm right. In your mind, you were saying yes.
June.
It's 5 months away from now. How's that?
June 15th.
Yes, sir.
Of 19.
Good question. What happened was, originally I was supposed to give you guys a quiz on all this stuff today. It was really tough for me not to give you a quiz today because I told you we were going to have one. But then I realized, oh, you haven't learned half the stuff, so I figured we shouldn't do that.
Yeah, I was gonna say.
So we're gonna
Yeah, we're going to do it on Friday. What'll happen tomorrow is that, again, this week is kind of a really weird week because today's Wednesday, so there's no flex. Tomorrow there's a presentation during flex, so there's no flex. And then Friday there's an assembly, so there's no flex. So I figured to err on the side of caution to give you guys a little extra time in class tomorrow to go through some more stuff. Yes, sir. We're just gonna have a short quiz on Friday. It's not gonna be it's not gonna be bad at all on Friday. Then come Monday we'll start 8-4 then. Yeah, I've got a little bit more to talk about with E. I just thought I would space it out a little bit because we got a little bit of time to, over the next couple of weeks to go through some of this stuff.
We'll have like 15 minutes.
Yeah, let me give you some problems. Yes, ma'am.
Did you say we had no flex?
Yeah.
Wait.
Tomorrow, let me break this up here real quick, and I'll tell you exactly what's going on this week. And I have to give you my little math spiel. All right. Real fast while you're writing this out, it looks like it's bad, but it's not. This first grouping is just simplifying. This second grouping, is it decay or is it growth? And the last one's is just a couple of word problems, and it's just perk problems. Okay? Yes, sir.
I heard that we couldn't like flex out Monday either.
I don't remember about